G'day, my name's Steve and this is Reevesy Workshops. Let's carry on with part 2 of linear measurement. So the next question you're most likely going to ask is, well, why don't we simplify things? Instead of having two different units and two different ways of doing things, why don't we convert all the drawings over to one unit? And as the tens units is the easier of the two to look at, why don't we just go metric with everything? Well, yes, you can do that, but the thing you have to understand is with our suppliers of drawings, if we take the Caterpillar drawings as an example of that, to change these over to metric would be a very time consuming thing to do. For instance, look at how many components are just on this one drawing, and then that's sheet 1 of a drawing. We actually have 6 sheets sitting there, so you can imagine how many parts you would have to convert from one system to another, and the suppliers of the drawings are just not going to do that. It's not practical. It would take thousands of hours to convert drawings over. So one of the things you're going to have to do in the hobby is get used to working with these two units and being able to convert from one unit to another easily. It's a skill. It's a skill like using your lathe or your milling machine, but it's a skill you can pick up. So I can give you a few tips on how you can use one unit against another. Which unit you like to work in the best is entirely up to you. I grew up in primary school with the imperial system. When I went to high school we were using the metric system, so I'm conversant with both, and I can move from one to the other and back again quite easily because I've been in this hobby for so long. In fact, I tend to think in imperial but work in metric. So how do you go about doing that? Well, one of the things you can do is to know that 1 inch equals 25.4 millimeters, or conversely 25.4 millimeters equals 1 inch. There are several different ways you can convert from one system to the other. One of these is to use a manual like this. This is an old Zeus manual that I got many years ago. It's what the professionals use, and this contains a lot of information, lots and lots of things. But the thing that interests us is this first chart here, because it has several columns converting from one place to another. For example, if we have a look at this dimension here, it says 1/64 of an inch. If I move over to the third column, it gives me the dimension in thou, and it says 0.0156 of an inch. So it's 15.5 thou. The nearest metric equivalent to that is in this column here, so it's somewhere between 0.38 and 0.4 of a millimeter, so roughly 0.39. Another way you can do it is to use your digital vernier. Now I've got this set up in inches at the moment, and you can see it's reading 251 thou. If I press the conversion button, you can see that now converts it to 6.38 millimeters. Okay, so we have several methods in which we can convert from one system to another and back again, but the question then becomes, what do I set my workshop up to? Should I make it metric? Should I make it imperial? Do I have a combination of both? which way should I go? Well, we're looking at my little Myford lathe here, and this lathe's well over 40 years old, and if you have a look at the dial down here, you'll see that it's in thousandths of an inch. If you're buying a brand new machine, you can go fully metric, but if you choose to buy an older machine, perhaps because of budget, you may find a similar situation where you've got imperial. So that's going to determine one of the ways you're going to go with your measuring system. For more modern equipment, it does get a little bit easier, because you can see on my bigger lathe that we have both units represented on the dial. So the one at the bottom of the camera is imperial. You can see it's measuring 0.002 of an inch, which is 2 thou increments, and the scale at the top here is metric, and that's measuring in 0.04 of a millimeter units. So we've got the dial set on 0 for the imperial, but it's reading 4.8 millimeters on the metric. So that does help you out. Similarly, when it comes to using a digital readout, and most modern machines that you buy new today have digital readouts on them, working in either system is really easy. At the moment I've got this set up in metric, so you can see I've got 45.585 of a millimeter. What is it in imperial? Well, I can just change it over and you can see it's 1.795 inches. So it's 1 inch plus 794 thou. Now you can see this machine's actually going to 5 decimal places, and I've rounded it up. But working in 3 decimal places is really the standard most of us work to, and that's why it's 3 decimal places in metric. So it's not as difficult as it might seem. I'm going to give you some practical examples of the importance of being able to work with the two systems. So if we have a look at these bushes, for example, this is on a boiler, you can see that it says tap 3/8 by 26. Then if I move over to the mechanical lubricator here, I'll just zoom down, you see the specification there is 332 by 60. Now the 60 refers to threads per inch. Now I like to buy books from the Model Engineering Press, and one example of that is this book here by Tribal Cane. In the back of it gives you all these drill tapping charts. Now I've expanded that out and produced this, and that's just photocopying out of the pages. So let's just have a little bit of a look. You'll see it says Model Engineer and Specialist Threads. If we go and have a look at 3/8 by 26 to start with, so 26 threads. Here's our 3/8, and you'll notice that all the tapping sizes are quoted in metric. If we have a look at the 60 series, 332 by 60, again quoted in metric sizes. Now why do you think that that has happened? It's because of the different increments of the drills. Here's an example of what I mean. These are metric drills in 0.1 increments, and it says 1 millimeter to 5.9 millimeters in diameter. 50 drills in just that size alone. So you can produce a lot more precise work when you've got such a close thing to use. And the reason why he's gone for metric is because of cost and availability. There are imperial size drills that you can use, and if we have a look at this column here, they're quoting number drill sizes, letter drill sizes and imperial sizes. Number drills are getting harder and harder to buy. You can still get them, but they're getting harder and harder to buy. Whereas the metric drills are much easier to get hold of. So it's a lot more practical to work with these metric sizes. Another common thread quite often used is 1/4 by 40. So just to give you an idea of the physical sizes of these things, here's a 3/8 by 26 tap on the left and a 1/4 by 40 on the right, and they're actually quite small. 1/4 by 40, for example, you're looking at something that's 6 millimeters in diameter. 3/8, you're looking at something that's nearly 10 millimeters in diameter. And it's not only threads where it's handy to have imperial and metric conversion. You can see here's an example of a 1/4 by 40 thread, but here we have some hexagon bar stock that's 1/4 inch. If I move over to this one here, you can see this one also has a 1/4 by 40 thread, but it's using a 3/8 hexagon stock. So let's have a little bit of a look at how that relates to bar stock. So I've got my vernier here, which I'll switch on. This toggles between inches and metric. I'm just going to set it for metric at the moment. I'm going to grab a little bit of brass bar here. Let's measure it. And you will see it doesn't say 10 millimeters, it says 9.45. Why is that? Well, if I convert to inches, that's now showing it in thousandths of an inch, and it says 372, 73. The bar stock's actually supposed to be 375, creeping up. So that means this bar is actually an imperial size, not a metric size. Similarly, this little one here, let's look at that one, says 248 thou. This bar stock is 250 thou, and that's 1/4 inch. So what's happening here is the manufacturer has made this to an imperial size, not a metric size. Now you say, oh, why is that? Well, it comes down to practicability and demand. When countries move from the imperial system to the metric system, the manufacturer really needs to remake their machinery so they can change the sizes of their materials. Now that's very, very costly, could even send the company broke. So they're not going to do that. If you were to quote them 6 millimeter hex or 10 millimeter hex, they'll supply you with the nearest imperial size. So you end up working with these imperial sizes. Now, one thing I should say is these bars here are actually a specialty item that are not used a lot in industry, nowhere near as much as mild steel. So when it comes to mild steel, there's a change again. You'll notice a difference between the way these two products look. This one has a black scaly surface on it. This one's a nice shiny surface. These two pieces of mild steel were manufactured differently. This one's cold rolled steel, has that rough surface. This one has been formed in a different manner. When I come to measure them, try and get in front of the camera here so you can see, you'll see that's saying 3 millimeters by 25. This one 12 by 40. So both these pieces have been made in metric sizes. This is a specialised item, and you can actually still get them in imperial sizes as well. But more common, they're in metric. So you have to take this into consideration when you're machining parts and bolting them together. So in summary, it's up to you whether you want to go fully metric in your workshop or fully imperial. But because of the nature of our hobby, you really need to be able to convert from one to the other and make adjustments as you build things. This is why I made the statement earlier, I think imperial, but I actually work in metric. The last thing I want to touch on is how we communicate to each other about scale and size of things. So you'll see in my videos I'm going to talk about certain standards and refer to those frequently. One of those is track gauge. Now we have 4 scales: 2.5, 3.5, 5 and 7.25. So you'll see here 3.5 inches for the left hand rail and the middle of these 3 rails, and then you'll see 5 inches for the 2 outside rails. Here we have 5 inch again, and here's our last scale, 7.25. I very rarely ever see track gauges measured in terms of metric, so I stick with the imperial. So I build a 3.5 inch gauge engine, or I build a 7.25 inch gauge. Another standard that I like to work with is that measuring pressure: steam, air, vacuum, and that's pounds per square inch. Now the metric equivalent of this is kilopascals or bar, and this is a personal choice, but I see our hobby as a way of looking after the past. We should always look at the future and what that holds and the things that it can give us, but it's nice sometimes to also look at what came before us. When the steam engine was first made, they used the imperial system, and pounds per square inch is what they used for measuring steam pressure. So I like to keep with that as well, and you'll see that as we go along in my videos. So here's another gauge, slightly bigger in diameter and a different pressure range, but again pounds per square inch. Down here we have a vacuum gauge, and that's measuring inches of mercury. If you're going to use metric, that's fine. Here's a gauge that has kilopascals on the outside in the red and pounds per square inch in the center. And if I look at this compressor, you'll see this is also dual gauge, so it uses bars is the scale in the center and PSI on the outside. The last thing I'd like to talk about is working in scale. Now, if you decide that you want to build an engine that perhaps you saw in a museum, or maybe off a set of drawings like this one is, so we've gone back to our little Hunslet engine. We talked about gauges being standard. So what you do then is you pick a scale to suit the gauge. To give you an example of what I mean, in 3.5 inch gauge, standard gauge, which is 4 foot 8.5, gives you a scale of 3/4 of an inch to the foot for the engine. So that's the scale you would build your engine to. In my setup, the West Australian Government Railways built to a rail gauge of 3'6". Now if I was to build this little engine in 3.5 inch gauge, I would use a scale of 1 inch to the foot. So that means 3 feet, 3 inches, 6 inches is half a foot, so that's ½ inch. So 3'6" equates to 3.5 inch gauge. It's a bit harder to talk about this in metric equivalents. Like you'd probably have to try and do something like centimeters per meter and things like that. So I like to choose the imperial system. It makes things much easier. And then if we have a look at this dimension here, for example, it says 5 foot 6 inches. So I know in 1 inch scale, that's going to be 5.5 inches. So that makes scaling the engine down much easier. And here's the engine drawn up full size at a scale of 2 1/16 inches to the foot to run on 7.25 inch gauge. Maybe one day I'll build this engine, who knows. When talking to people that don't know very much about our hobby, equating all these scale sizes can be a bit hard for them to comprehend. So what I like to do is talk about ratios instead. So say I was going to build this engine in 3.5 inch gauge. I'm going to use a scale of 1 inch to the foot. That is 1/12 the size of the original engine. So what I will do, if someone asks me what size is it or what scale is it, I would tell them it's 1/12 the size of the original engine. And that helps people put things into perspective and get a bit of an understanding of how you're working and what you're doing. So you might like to choose that way of describing things as well. Well, that concludes my tutorial on linear measurement. Hope you found it useful, and I'll catch you next time.